All right, so hopefully you can hear me. Let me share. All right, so hopefully you're seeing the slides I have here. I'll be just writing on the whiteboard, but just be aware all of this is kind of already it's pretty much everything I'm saying is already written down here in the slides. So I'm going to, this is more, this will be more like Linux itself, right? Rather than the previous slides were more sort of like concepts. This is a little bit more applied to what we will be doing as far as commands, etc. And some of this you will have to practice. Remember, these are the common things that are consistent across all of everything that we will do regardless of service that we are looking at. We will be doing this all semester. So I think that's everyone. For whatever reason, everyone's coming in slowly. All right, so I think everyone is now logged in. So let's then go ahead. So I was saying here are the slides, the notes are there. You can take a read through them. I'm just going to use the whiteboard and kind of discuss the same thing. All right, so what I'm going to do now is I'm going to cover the UNIX way, okay? And what that is, as I said, it's a philosophy. It's a philosophy or a underlying principle of how UNIX works. And then everything after that, everything about UNIX basically wants to be consistent with those initial design principles, okay? So let's talk a little bit about that. And so we'll talk about commands also. This is more like the Linux, or I should say Unix actually. This is more the Unix, because it could be anything. The Unix, even Mac, right? So even Mac is built on a Linux kernel, so even Mac this applies to Mac. All right, so basically then, today's topic, or this topic now, is called the UNIX way. And really the UNIX way, this is a question I always like to ask in the exam. And I will always say something along the lines of, what's the UNIX way in one word? Or how do you capture that idea? And the way to capture the idea is basically by saying the word file. Okay? So files are really the UNIX way. Okay? So files. So what that means is that files are central to UNIX. Files are central to UNIX. Okay, as you will see, as you've maybe never thought about it, right? Maybe you've used Unix for a while in your courses, in your lab assignments, etc. But you've never really thought about the fact that Unix is centered quite a bit on files. In fact, Unix is nothing more than Unix has a hierarchical which is, you can say a tree structure. So Unix has a hierarchical directory organization. And that's really, you know, some of the essence of Unix, okay? That it's this hierarchical directory organization, right? It basically a tree structure of files, right? So you have, you know, like that, like nodes and links. And if you remember from your data structures course, right? You know, there's basically this idea that you have this type of a data structure that is the most efficient to organize everything in Unix. And so it has this hierarchy of folders, and it's got this directory organization, okay? And this is usually called the file. So this is called the file system. And the file system will actually be one of our topics, right? Later on, when we do file system analysis in the semester, we will talk about the file system itself, okay? And, you know, properties about it. But for now, just be aware, we're kind of just starting. We want to start somewhere with Unix, right? You know, it's not always just about commands and things like that. We want to understand more fundamentally the structure of Unix itself. And the base of this tree, so the tree starts somewhere, right? So the base of this tree is actually what is called the root directory, because it's, you know, this hierarchical directory organization is central, right? And so it's got a base. And so the base of this tree is the root directory. What is called the root directory. And I don't know if you've ever paid much attention to it, but it's really just the /. So this is the /. Okay. And so it's the /, and that's the root directory. So that's why whenever you see, you know, in the command line, right, it's very important actually, if, you know, to put the / and then, you know, whatever follows after that in the path, user home, you do like user home, you know, ... So these actually are just to separate, but the first one indicates that, in fact, that is the base of the tree, which is called the root directory and is nothing more than a /. Now that the Unix way is, you know, files are central to Unix, in that Unix has a hierarchical directory organization called a file system, then that basically tells you that it's an organization of files, right? You have all these nodes, and these nodes are usually some kind of file. And not just files for writing, but they're files for configuration, and sometimes they're just files for everything. Everything is a file. You know, you create some kind of a, you know, a device, right? A device in your system, like the printer, etc. Well, it's represented as one of these nodes, which is technically a file that holds information. So if you have all these files as part of your directory, right, then it makes sense that, you know, you want to control them in some way. And so security of Unix is also central, and security is achieved in relation to files, these files in the file system, all right? And the way that you control these is by something called the access control. So access control principles, which is another one of the central elements of Unix and a Unix, you know, operating system, okay? So when we talk about this access control and files, we're really then talking about file ownership, which is really the central concept. So file ownership, okay? So in Unix, for instance, files have two owners, right? So on Unix, as part of its design principle on Unix, files have two owners, okay? Which are, as you might imagine, the user itself. So there's always a user and there's always a group. So there's always a user owner and a group owner. So whenever, and you will see this as we start doing examples of creating accounts, etc., you will see that whenever you create a file, you create something, the ownership will always include a user and the user owner and the group owner. The way to see this right now, if you have your Linux machine in front of you, is just go to the prompt, the command terminal, and type ls-l, and that will give you a listing of all the files in your folder. And if you look there, it'll give you the names of the user and the group. Okay. And these user and group are independent. So these are, they are independent. And when we'll see an example of this, actually, to better understand this problem, right? So let's do an example, actually. So let's imagine, example, right? And this is already written down in your slides. So I think we can just read from those slides. So let me switch over to the slides. Where are the slides? All right, so if you look at these, okay, we're talking about, 372. Okay, so we've talked about this. Talked about that. Here's the example, right? So example, it's not a quiz, it's just an example. Suppose Smith, who is, we're talking about people here, maybe in an organization, right? And they want to access some files that are in a file server of some kind. So suppose Smith, who is in the chemistry group, right? So she's got an account, Smith, but belongs to the chemistry group, needs access, and that chemistry group is also a group that exists in the system, right? We're talking about a single computer, a single server here. So, and Smith needs access to some files usually used by the physics group. So those files are owned only by, they'll be associated only with physics. So Smith doesn't have access to them because she's in chemistry and she's not the direct owner of the files. So if you're a system administrator in that system, how do you give her access to the files? Okay, that's really the key thing, right? So how do you do it? So you could make copies of the file and email them to her, but that may not be what the most efficient way of doing it. You really don't want to move the files from the server because they're going to be updated, etc. You don't want to do that every time, right? So what are the most efficient ways of doing it? Well, an efficient way of doing it might be to make Smith, right, a member of the physics group, because the physics group already owns the files. So if you just make Smith a member of that group, now she will have permission to access the files. So that's why in this example, it's just here to help illustrate why we have users and groups, right? Why is a file? Remember, we're always talking about files because that's really the central element of Unix. And then we know now that files are owned by both users and groups. So the file maybe was started by Johnson, whoever, right? So, and Mary Johnson. So she started the file. She's the owner, but then there's also the files can be accessed by the physics group. then Smith, who is not in the physics group but wants to access the files, could be added to the physics group, and then that simple act will allow her now to see the file. So that's basically the idea here. You know how of why Unix works the way it does, because you don't really want to have to make copies of the files, or definitely you don't want to make the files world readable, right? So you don't want to, just because you want to give access to one person, you're not going to make the files readable to everyone in the system, right? So instead, the better solution is using this mechanism. Works out really well just to add Smith to the group. We will see actually later in one of the labs, the user account management lab, you'll have some examples of how to do just that. So if you create groups, create users, how do you add them to a group, etc. And then link them to maybe blocking a service or accessing a file, etc. Okay? Questions?
I don't think so.
Pretty easy. All right. So that's kind of the idea there. So let's go back to the whiteboard. Go back to the whiteboard. All right. So we talked about the example and the solution there, make Smith. So the better solution is just to make Smith a member of the physics group. All right, so how do you now, what are the commands associated with something like this? So later, as I said, you'll do a lot of examples of creating that, but here, all I want to do is, as we're talking about just the philosophy of Unix, the Unix way, some of the commands that can help you with this. So we would use, for instance, as I said, the ls-l command to look at the permissions. So this will help us to look at the permissions, the access control. But usually whenever you refer to this, you talk about the permission settings in your Unix operating system. All right, so that's basically the idea there. So other commands that are associated with this, with file ownership in Unix is, so changing ownership, okay? So changing ownership, all right? And some of the commands for this are going to be chown and chgroup, okay? So grp. All right, and so basically this will, again, because everything central to Linux is a file, we're going to be changing the ownership and then the permissions. Usually that's the way it works. So let's imagine that we have a file 1. And so remember, whenever I write, I'll usually write one of 3 things. I'll write, you'll see me write a generic one like this, which basically means it's just a prompt, but I'm not telling you what the permissions are. Or I'll write this, and this usually means root. All right, or I'll write a dollar sign, which basically means regular user. Okay, so you'll see me write one of these 3. You should know whenever I intentionally write one of these, kind of what the meaning is. Okay, so let's think of the example of how to use chown. So I have root privilege there, and then I'm going to do chown. Then you're going to specify here basically the new owner in the command, and then something like the file name, right? So file 1. So this could be the user name or user ID. So this could be the username, or it can be the user ID. Okay, either one, but that will be the command. And this is something that you will have to use quite a bit throughout the semester in some of the, especially once we start doing more difficult configurations, right? So right now it's just pretty easy, loose set of commands. Later on in like week 4 or 5, when we do the DNS lab, you'll have your first challenge of doing an actually complex configuration. Not very, but somewhat. All right, so for example, then here, we can do chown, let's say Harvey, you know, whoever that is. Harvey, the user in the system, and then the file, you know, file 1. .txt, or, you know, files don't have to have extensions really, but it's something that we can have in there. All right, so that's the idea. Now, another interesting one is, what if you need to change the ownership of an entire directory? So let's take a look at that one. Kind of fits in well here. So to change, anyone know what would be the command for that? Change ownership. So change ownership of an entire directory.
It'd be like a hash R, not hash, I'm sorry, but tac R.
Dash R, yes, exactly.
Yeah.
It's a recursive flag, right?
Mm-hmm.
Yeah, very good. So you do root and then chown and then -r, Harvey, and then, you know, whatever the folder is. Let's imagine it's something like home. Remember, this is the root, home, and then, you know, data, new, you know, something. All right, so that's basically, you take a folder there, and in that folder then, because of this recursive flag, which will be common, it'll apply to everything in there recursively. Okay. So again, you know, if you look at everything's pretty straightforward so far, but you know, we're kind of looking at some of the main elements because we want to have a more structured way of thinking of Unix itself, right? So in summary, the Unix way says files are central to Unix. And Unix has a hierarchical directory organization called a file system, right? This is how things are organized. It starts at a base called this /, which is called the root directory. And then from there, we jump immediately to the security of it. Well, files are associated with access control, which means files are really associated with owners and permissions. Owners and permissions. So this is what we will be exploring. And then, so as we start to get into file ownership, then there are 2 types of owners: the user owner and the group owner. They are independent, as you just saw in the example. That's why, you know, I gave you the example. You saw that, you know, we can add groups, chemistry, physics, and then add a person to a group and control things that way. Okay, and then we started looking at some of the commands like chown and chgroup, and we did an example of them. So let's look at another example here, just to kind of illustrate this. I'm going to go over here and say, well, if I do chown -r recursive flag Chavez chem, right? So that here, this is the user, but this is also the group. You can actually set them both at the same time. And then, especially, you know, you specify the folder. So it's going to be the Chavez folder there. All right, so what this does here is that, if I change color, okay. So what this does here is that it changes the user owner to Chavez. And the group to chem, right, to the chem group. And so you can basically do that all at once. Now, if you wanted to just change the group, you could do, now notice here I'm using the $sign, right? So here, now remember, this is going to be relevant, right? Sometimes you can only do things with root. Sometimes you can do them with regular user. It depends on who owns the file. And so that's really the game that you have to become. Although this seems trivial, a lot of the time, problems that you get in Linux are just because this is not set right. The access control is not correct. And if you don't understand the access control, you're going to, struggle quite a bit, right? So you really have to get this down. But here, for instance, I'm only using a regular user, and then I'm going to change the group. So chgrp. And here, so the notation would be new group, which is that one, and then file 1 or whatever it is, right? So that's another way of doing it. So now that we've looked at ownership, the next thing we can look at is, if we go back to the slides, we saw in this slide that we have actually owners associated with something. So we have owners and permissions associated, and so we're going to go back and now look at permissions. Okay, so we're going to look at permissions. Which is also called file protection. Okay, and so or also known as file mode. So that's another terminology. File modes, the modes. All right, and this is also pretty important for as we set up again, access control, right? So the essence of access control is at the heart of the Unix way. So you probably have seen this before. There are 3 types of file access. There's technically a 4th one, but let's just start with the 3 basic ones. So there's the 3 types of file access. Can anyone name them? What are the 3 types of file access?
Read, write, and execute.
Right. Very good. So read, write, and execute. And they are associated with the flags, right? So they're associated with little flags that you will have in your output, but they're usually denoted by the R, the W, and the X, right? And these permissions then govern how the owners of the file, which are the user, the group, and then everyone else, can interact with that file. Okay. All right. So here we have. So they're also now we have another element. Now that we know the 3 types of file access, the next thing we need to be aware of is the access classes. The access classes. And there are 3 basic access classes, which I already mentioned, which are user, the user class, the group, the group class, and then what is called others or rest of the world, some people would call it, just, you know, everyone else. So that's going to be other. And these are designated or denoted by U, G, and O. Okay, so those are, so this is usually, so user is usually the owner of the file. So user is going to be the owner of the file. And then group is, you know, group, as we saw in the example. And then this is just all other users. All right, so a lot of everything pretty much that you do this semester, you know, you'll have to deal with access control, and you have to deal with it. So now let's look at an example. So for instance, we have something like this. Let's say you go into the terminal and you type ls-l, right, in a directory. Type that command, and now the output looks like this. So you get, you know, something that looks like that, and then you get 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 root, and then you get system, and then ... So who can tell me, just by looking at all of this, right? Looking at all of that, what does that mean? And let's say, just for the simplicity over here, let's say that, you know, ... and it's file1.txt, just to keep it simple. So it's some file. So what would you be able to tell me about file1 just by looking at this output over here? Who wants to try? What does that mean? What do you guys think? What does that mean?
Would that mean there's 3 different users that can access it, and one can read, write, and execute, one can read and execute, and the other the same?
Right. So you're right. It's not. So the way to say it is, you said it perfectly, except they're not users. They're the access classes. This part here.
Oh, right. Yeah. Owner, user group, or owner group, other.
Exactly. So what you just said is exactly right, except just to say there's 3 access classes. This one, this one, this one. Those are the 3 access classes that we saw. So this is for the user or the owner, which is, who's the owner here, root or system?
Root.
Root, exactly. So this is the user, right? So that's the same one. So that tells you what? That tells you that root can read, write, and execute. So root is the owner. Root can do anything on that file. Then this one over here is going to be group. And the group, there's a systems group. And that, you know, that could be chemistry or physics, whatever you want to do it. Whoever is in that group can do what? What can they do?
They can read and execute on
They
the
can read and
right?
execute, but they cannot write to that file, overwrite it. That's not allowed. But they can use it. They can read it. That's okay. And then the other one, other, just means the rest of the world. Any other account on this system that comes in and looks at this file, they can only read, they can only execute, nothing more. Now, so this captures all the elements, the access classes, the permissions, the ownership, right? So now what about, and then this is the name of the file right here. What about this? What is that? Is that just, what does that have meaning?
Yeah, that's like the file type, right?
Exactly, very good. That's called the file type, and it's usually a hyphen. What symbol would you use here if it was a directory?
A D.
D, exactly right. So you use the D for a directory, and you use the dash or hyphen for a file. All right, very good. Very good. Okay, so as you can see, you know, today's discussion is just pretty straightforward about this. And so we've covered that. So let's say there's a couple of ways that you can set up permissions, right? And for this, we introduce another command called a chmod, which you will be using. So let's say that we want to modify a file, right? So we're going to do chmod, and we want to modify the file 1. Okay, so there's a couple of ways that we can do this. There's the more intuitive way, simplest way, which is just to do something like u plus w. All right. So in this case, what this implies is this is the access class for file 1. So for you, the user, we are going to apply write privileges. All right. So the plus just means add. So we're going to add write permission, which it already had, but this is just an example. Okay. So that means, you know, we're going to add that write permission. That's one way of doing it. You'll see examples later in the semester of this. But you know, as you might imagine, using these now, right, these 3 letters, right, and then using, you know, read, write, and execute, you can basically provide various configurations of what you want your access control to be and the access that you want others to have to your files. There's additionally another way of specifying file modes, which is called the numerical specification. And the way that that works, we can take a look at that as well. We can see, for instance, you know, I usually like to write this out just to think it more thoroughly. So basically, you set this up. Let's say that you want, this is the mode of operation that you want. You have the classes, user, group, and other. And other, right? So you have these 3 classes. And then now you can think of the permissions as we had them before. We have write wx, we have write dash x, we have write dash dash. Right? So those are the permissions that we have in there associated, the modes. Now the question is, we want to be able to just write chmod for file1.txt, let's say. And we don't want to write the permission as we did before with this approach. Instead, we want to take the numeric approach, which you've seen people write, like, you know, I'm just writing some numbers there, right? So 777s or some kind of a value there. So to arrive at that number, we need to think in terms of this. So this is a good example just to kind of think it through without memorizing these things. I know some people just kind of memorize these, but instead, you know, work out this example here, and then you don't have to memorize it. So first of all, you have to think about converting this to binary. So convert to binary. Right, so we convert the binary. So that just means, okay, this is 111, this is 101, and then this is 100. So that's the first step. Then we know, you know, kind of what you do with IP addresses, right? You've learned this, how to convert binary to decimal via IP addresses, and when you did your IP addresses and so on. So you assume this is 0 position, 1 position, 2, 3. Then you just take 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, and ... so on, right? So similar approach here. We just have to think in terms of that. So converting to octal, for our case, we can, you know, let's say to digit, we can say convert to digit. All right, so then we can think in terms of this, to, you know, raising the 2 to the power of something. by the position. So here we're going to see obviously 2 to the 0 times 1, 2 to the 1, 2 to the 2. And then this one is just going to be, let's say, 2 to the 0, 2 to the 1, 2 to the 2. Oh, sorry. 2 to the 2 is 4. These two are 0, right? So that's 0, 0. But that's 1 times 4. So this one comes out to 4. And then over here, the same thing. 2 to the 0. We can exclude that one. 2 to the 2. 2 to the 0 is 1. Oh, keep doing it. All right, so then that's going to be 1 plus 4. That's 5. And then we do the last one, which will be 2 to the 2 is 4. 2 to the 1 is 2. That's 6 plus 1. That's 7. And so we arrive at the equivalent number that we can apply over here. So 4 plus 2 plus 1 is 7. 4 plus 0 plus 1 is 5. 4 plus 0 plus 0 is 4. And now that we have this, we have the corresponding absolute mode. So the absolute mode would be 7, 5, 4. Okay, and so then we can now you can think of in terms of the number, and you can 754. And then this is just handy or practical sometimes. You know, some people memorize the numbers. Otherwise, you know, that's the logic behind it. When you add a fourth number, which is, let's say you did 4754, the program, the operating system understands that as trying to set up what is called the set UID. The fourth parameter relates to something called set UID. Believe it or not, this is something that we will explore quite extensively later on. Because set UID is a kind of a exception to access control, actually. So it's a little bit more complex. So for now, just be aware there is that additional flag, if you will, which the way it translates is that you can set this X actually to an S, right? And whenever you see that, which maybe you've never noticed it before, that can exist. And that relates to this concept of set UID, but we're not going to talk about that yet. So for now, just kind of worry about the X over here. But just be aware, that's called set UID. It's a topic, it's an upcoming topic that we will talk about. That you can think of that as an additional, it's one more mode. There's one more mode of operation, and that relates to effective ID, the user ID and the effective ID. So it's a little bit more of a complex problem. All right, so that is, okay. So this is a good stopping point. The next topic that we will talk about is just wrap up the Unix way with a few other additional, as I said, elements. So we can probably just cover those in lab on Wednesday, I think, and then it'll actually lead in really well to some scripting examples we will do. Remember, just kind of, we want to automate everything that we do in this course, all the Linux commands, and so that'll be very helpful. So, but that in conclusion is the Unix way. So, you know, so in conclusion, I usually like to say this. So in conclusion, you know, the Unix way pretty much says that, and I'm just going to use this squiggly line to kind of indicate almost always, right? So almost always that everything in Linux is a file, okay? So that's kind of, in one sentence, that's the Unix way. Everything in Linux, you can safely pretty much say that everything in Linux is a file. All right. But, you know, so we've talked about, and hopefully, and that's it, honestly, to be very honest, that's what we talked about today is the philosophy of Linux. And then after that, we can just go into the details. But the next set of topics really will tie in, you know, we're going to talk about sockets and daemons, and those are things that tie a little bit more strongly, even links, a little bit more strongly, processes, batches, etc., tie in a little bit more strongly to the lab. So I'm gonna save this material actually for the day of the lab. Start with that, and then you guys can work on your lab assignment on Wednesday. We will have, you know, a little bit more scripting on Wednesday, and there will be a scripting problem as well. So just double checking that I covered everything that I wanted to cover. All right, yeah, I think that's good enough. And then obviously the slides are posted, so I think there's a little bit more information. I think I may have used different examples in the slides. So just take a read through the slides. You should always be reading the slides, okay? That's basically the what I would recommend. All right, so I'm gonna now pause the video here.